Hello everybody, this is video 7.6. We'll be looking at percents. I think the book calls it percents revisited, percent increase and percent decrease. Uh, so we'll be using some of the ideas from percents. We'll review it a little bit at the beginning. You may want to go back and look at some ideas of percents, but it's mostly around ratio and proportion with a little bit of percent. So let's get started. So it's a little bit of a review, just to redefine. A percent is a part per 100. And so when we looked at this before, at percentages before, I mentioned that there was a proportional aspect to this. And we weren't really talking about proportions, we weren't really solving proportions, but the mechanic that's being used is very much like a proportion. Um, the way we approached the problems before was to create a unit rate, 1% equals something, and then to multiply from that 1% out to whatever percent we needed to find. Uh, we're going to use the same sort of idea here. We're going to be looking at percent increase and decrease. And so we're going to be basing this on the change from 100%. So anytime we get something where we move from 100% to say 108%, then we know it's an 8% increase. Or if we move to 96% from 100%, then it's a 4% decrease. So we'll find out where we are relative to 100, and then we'll sort of figure out the increase decrease from there. Like the previous slides, I'm going to approach this mostly from looking at some examples. I think that gives us the best context for understanding what's going on with these problems. So we'll look at some problems dealing with percent of increase and decrease. So our first example, we're going to consider a job that has a base salary of $50,000, and it could be 5,000, it could be 500,000. I'm using 50,000 because it's kind of a nice round number, and uh, the five works out fairly well with the calculations that I want us to look at. So what would the new salary be if the old salary gets increased by 3%? Now, we certainly could figure out what 3% of 5,000 is and then just add that on. So there's nothing at all wrong with doing that. We could certainly say that if we've got 50,000 rather, so 50,000 is 100%. That's everything we're starting off with. So we know that 1%, we just take those two zeros off, so that's 500. And so 3% we know would be 1,500. And so we know we could add that on to the salary 5,150 and go from there. So I'm not disputing that this is a correct solution. It's not using proportionality necessarily, so I want to do it the way that's sort of shown in the books. But I just want to be clear, there's nothing wrong with this solution. Approaching this as a proportion, though, we would set this up as 50,000 is to 100% as some new amount is to 103%. So we can certainly do it this way. Now, this step we can still do. We can multiply, or rather divide this by 100 and get 500 is to 1%. So we get this by dividing by 100 and then multiply this by 103. And that gets us from this unit percent, this 1%, up to 103%. And then that gets us directly, I'll write this in green here. So if I multiply 500 by 103, then I get 51,500. And that gets us right to this answer rather than figuring out what the 3% is and then adding that on. So this is the trade-off so often in mathematics. We can do it in fewer steps that are a little bit more complex because I'm having to think through that 103%. I'm having to I'm doing two steps at one time, combining the 100 and the 3% to get the 103. Um, I mean, it's not the most challenging thing to balance in your head in the world, but I mean, this is a new topic and a new idea. Working through more easier steps might be a better approach than fewer, more complicated steps. So we get the 103 percent is 51,500. I want to mention also, we've got this done in 3 steps here. So we could do it as the unit percent, and then find the 3%, and then step 3 we could be, or would be to add on the 3%. And then here we've done 2 steps. We have found the unit percent, and then we've gone straight to the 103%. And some of you might recognize we can do this in 1 step if we just multiply this by 1.03. So this is what I'm talking about. We can do this in fewer steps that are a little bit more complex, or we can do it in more steps that are maybe a little bit easier and more intuitive. This is probably going to be where we're going to start. And then as we start to move here and then up to here, we're making this more abstract. We're making this quicker. We're doing it in fewer steps. So, this is a recurring theme of this class, this idea of doing it in fewer, more abstract steps as sort of a progression in how we approach these problems. All of these are valid methods. Yeah. All right. Okay, example 2 is very similar. We still have our job with a base salary of $50,000, but now we're looking for the percent increase given the monetary pay increase. So in example 1, we were given the percent to find the money. Here, we're given the money to find the percent. So hopefully you remember from the previous problems that we've done with this sort of idea. So 50,000 is 100%, but now we're trying to find what percent this would be after we've increased it by $5,000. So since we're looking for this constant dollar, well, not constant, but so we're looking for the dollar amount to change. We're given this monetary amount at the end. That's going to help us find this unit rate. So I want my unit per $1. And so now once I have this, then I know I'm just going to have to multiply this by 55,000. So now I've got this down to $1 to get to 55,000. Now, some of you might sort of recognize that 500 will divide into 55,000, that 5,000 will divide into 55,000. So we don't necessarily need to go to a single dollar. But as I mentioned before, as we're talking about unit rates, the most generalizable way is going to be to get it to the 1. So it's called a unit rate for a reason, so getting it to 1. If you recognize some common divisors between the 50,000 and the 55,000, that's certainly a valid approach. It's just not going to be the way I'm going to do it in this example. So I divide all of this, divide by 50,000. And so then I get here 0.002%. So I divide that 100 by 50,000 and I get 0.002. Now, when I multiply this by 55,000, I get 110% as my answer. Now, again, not to rehash this too much, I could do this by not looking for this percentage all at one time, doing an additional step. So 50,000 is to 100. What 5,000 is to something, some percent, and then solving it this way, and then getting that this is 10%. So I, use the same steps to get that this is 10%. And so then I know that since this is the monetary increase, then this is the percent increase. And I have an extra step of adding the 10% onto the 100. Just like I said in the previous slide, doesn't really change anything. It's one extra step that might be easier. It's a balance point you have to figure out for you and your students. Now, for the third example, we're going to take a job that has a base salary of $55,000. and we want to find what the percent decrease is on a $5,000 pay decrease. Now, I'm bringing this up because we saw in the previous example that we had 5,000. Well, the 10% increase was 5,000. So the $50,000 10% was 5,000. So now we're doing 55,000, and we want to find the percent on minus 5,000. So a lot of students are going to see this 5,000, add 10% gets us to 55. So if we're at 55, it must be minus 10% to get back to 5,000. A lot of you probably already know this is not the case, but if not, let's work through it. So we've got now our 55,000 is to 100%, and we want to find what percent 50,000 would be. So this is some percent. Now, when I find this unit rate, and again, I'm going money to money, so I know I need my unit rate in dollars. So $1 now is going to be 0.01818 repeating. So now I got this by dividing by 55,000. And so now I'm going to multiply this out by 50,000. And when I do that, I get 90.9090 repeating percent. So effectively about 91%. There or thereabouts. Okay. So this requires a little bit of explanation for a lot of students why to go from 50 to 55 is a 10% increase, but to go from 55 to 50 is a 9% decrease. And you know, obviously the difference is what we're basing it on. We could see if you go back to the previous example, the 100% was 50,000, and here the 100% is 55,000. So students don't always sort of recognize the base amount determines what the 100% is, and if we change what dollar amount the 100% is, then it changes everything else. The other percents are going to be based around that. So it definitely alters the shape of the problem. So for your checkpoint problem, we've got here, a few years ago, Alice was 140 centimeters tall, Bob was 120 centimeters tall. Now Alice is 150 and a half centimeters tall. So if Bob has grown in proportion to Alice, how tall is Bob now? So there's a couple of different ways you can approach this. Since this section is on percent increase and decrease, I'd like for you to find what the percent increase is and then apply that percent increase to Bob. You can solve this just as a straight proportion. 140 to 120 as 150 and a half is to something, and just solve it as a proportion. But I really want you to think about this as a percent change, percent increase, percent decrease. Well, in this case, percent increase. So I'll leave you with this problem. As always, if you have any questions about this problem, by all means, please let me know. We'll get your questions answered. All right, thank you.